to talk about center of mass, center of gravity, and about rotation today. And first of all, I'm going to start with a little stunt. Okay, so what we're looking at here is a metal bar, I think. It's actually made of aluminum, and I'm going to pretend I'm a magician. And I'm going to concentrate very, very, very hard at one end of this, let's see, this end, or I'll concentrate very hard on that end. Okay, I'm going to concentrate very, very hard. I'm going to try to make it feel lighter. There we go. Okay, now I think you know how this happens. At least I hope you do. You see, this end is filled with lead. And of course, this is hollow. And so there's a lot more mass in a short space here. However, if I should cut this in half, would this be heavier? Would this be heavier? Or would they be the same? Do you know what? I'm not going to tell you. You can figure it out. I think you can just think about it. This is a very long piece. It's a long lever. This is a shorter piece. It's a shorter lever. So that's a clue. By the way, if I threw this through the air, it would spin around this center of mass, okay, like that. And it would, if I spun it really hard, it would break one of those lights, but we're not going to do that, are we? I built a model here. This is and you know, a scientific model doesn't necessarily look like the real thing. It just helps explain the real thing. So this is a model for, you never guess, this is the Earth and this is the Moon. And I've put a heavy weight in here to make the Earth much heavier than the Moon, which in fact it is. In fact, the Moon is about 1/64th the weight of the Earth. And you know, the Moon goes around the Earth once every month. So we're going to simulate that motion very fast, not once in a month, but once every half second. And I'm going to spin this. There we go. Now notice that little red, keep your eye on that red spot in the middle, the red spot between them, because we're going to explore that. There we go, it spins around that red spot. And if I hold this like this and bring my fingers together, I'm going to end up at the balance point. So the Earth and the Moon rotate around a common balance point. Now you're going to say, why have I noticed this before? Well, the reason is that this balance point is actually inside the Earth. And so the Earth doesn't really rotate around it, it kind of wobbles around it. And so let's have a look at that, because what we're looking at here is the Earth and the Moon, and between them is a balance point. In fact, if we had a pivot point there, that would balance. This is called the center of mass of the Earth-Moon system. It's also, if you look at it from a distance, is also the center of gravity. But center of gravity is a funny thing, because if you're standing on the Moon, you say, where's the center of gravity of where I am? Well, it would be in the Moon, because the Moon's pulling you down. If you're on the Earth, that would be where the center of gravity goes. However, this balance point does not change. So that's kind of an interesting thing. Well, maybe you could try something like this yourself. If you're going to build one of these, please do it outside.